So hey everyone, today I'm telling you a very important concept which definitely bother the student. The concept of displacement current. Actually, when I talk about displacement current, most of the time you remember this concept whether you are in class 12th and you are in graduation or you are in your post graduation, you're preparing for any particular exam. You just mug up the thinking what is okay. This is the formula. This is the Maxwell fourth equation. So to understand the displacement current and the Maxwell fourth equation, you have to understand first why the Maxwell electrodynamic is important. See, Maxwell electrodynamic, we saying it electro EMT, electromagnetic theory, है ना? So that mean Maxwell basically what we do, we already know the from the Faraday law of electromagnetic induction, कि changing magnetic field produce electric field or electric current. You know this? Maxwell just established a reverse relation. He told you that when the electric field is changing in nature, not a constant. I'm not talking about a constant electric field. I'm talking about a electric field which change with the time. So always remember changing, we discussing about the changing electric field only. It also produce a magnetic field, and the current it produce, it is called displacement current. So whenever we have to understood the concept of displacement current, we have to understood कि we talking about the changing electric field which going to produce the displacement current. Now where from the concept of displacement current came in the mind of Maxwell. See, he do a experiment. See, this is just simply current conducting rod. If I place a magnetic needle here, obviously it show a deflection. Why? Because from the Ampere circuit law, you know that if I draw Ampere circuit loop here, close B dot dl is equal to mu 0 I, and there is a conduction current in this wire. So obviously around this wire there is a current. So if there is a current, then it produce a magnetic field, and that magnetic field produce the deflection in the coil. But if I place the coil in between the capacitor plate, ideally there is a no current directly. Is there is a current? No. So if I apply the Ampere circuit law within this range, I'm applying the Ampere circuit law here in this region, there is a no direct current, there is a conduction current is zero. So ideally if I use the Ampere circuit law, you know this, if I use this B dot dl equal to mu 0 I, so it comes out to be 0, and the magnetic field within this region in between the capacitor plate, if I'm talking about the capacitor plate, in between the capacitor plate there is no conducting current, and the the magnetic field in between them is 0. If the magnetic field is 0, the deflection in the coil must be 0. But when Maxwell do that experiment, he find that no, the magnetic needle shows some deflection in the region also. So that means there is a current. So he conclude that since these are the capacitor plate, in between the capacitor plate we connected through a external circuit, and the charge in the capacitor plate growing, that is growth of current, the growth of charge. Corresponding to that, the current, the electric field between the capacitor plate E equal to sigma by epsilon 0 also is changing in nature. This is a changing electric field. Okay, this is a changing electric field. So from there he conclude that, he told us that this changing electric field produce a current that is known as displacement current. So the concept is now very clear. Only the changing electric field produce the displacement current. This changing electric field produce a displacement current. If the electric field within a region is constant, there is no electric field, no displacement current produce, only the changing electric field produce it. So the reverse, that means the changing electric field produce the magnetic field, will come true here. And we can say now there are two type of current. How many type of current? Two type of current. One is conduction current, one is displacement current. If the electric field is changing in nature and there is no direct current, so this term is 0, and the current I is nothing but displacement current. What is the value of this displacement current? We can say epsilon 0 dE by dt, or we can say del D by del T. D is the displacement vector, no? This is called del D by del T, and D is the displacement vector, this. So that's why it is known as the displacement current. I hope you understood the concept of displacement current, and this is a displacement vector in EMT. So now your Ampere circuit law looks like this: mu 0 IC plus ID, and when ID is 0 we use mu 0 I, when I is 0 mu 0 we use this term. So if I take now a curl on both side, okay, we not get 0, and we not get 0 out there also. Okay, so by this concept we understood that key whenever the electric field change, it produce the displacement current. So this is the Maxwell fourth equation, which is basically the modified form of Ampere circuit law. I hope you had understood that concept and there is no doubt about the displacement current and Maxwell correction. Thank you everyone.